Hi everyone, I'm Pravlika. In this video, I'm going to explain about collisions, hashing, and collision resolution technique, which is chaining. First, I'm going to copy and paste the set of strings which they have given. Um, so these are the set of strings which they have given. These are of combinations AC, ACGTN. So firstly, indices for the alphabets ACGTN. So we are going to start with the index 0. A is given represented with index 0, and the alphabet C is represented with 1. Likely the other alphabets are going to represent with other index values which are of 2, 3, and 4. And then after giving indices, we are going to convert these each of these strings into a Radix notation. Firstly, to convert these string into Radix notation, we are going to indicate this, represent this string as the list of these indices. So the alphabet A can be represented with 0, and alphabet C can be represented with 1, and alphabet G can be represented with 2, and alphabet 3 T can be represented with 3 from the above. And T, and the next alphabet is also T, so we are going to represent it with 3 as well. So likewise, we are going to convert each of these strings into Radix notation. So by using this Radix notation, we can convert each of these string into a single number, which is it can also be called as a K. So I'm going to convert these string into a single number. We can convert it by using we are going to multiply the index of the alphabet, which is 0, with the base is nothing but the number of alphabets which are present. So here the base is gonna be 5. So since the number of alphabets are of which are present are of 5, so 0 times 5 to the power of n minus I minus 1, which is n is nothing but the string length minus index, which is going to be index of the alphabet, which is going to be 0, minus 1, which is 5 minus 0 minus 1, which is gonna be 4. So I'm going to represent 4 power with cap. So 0 into 5 to the power of 4 plus, for the next alphabet index is 1 into 5 to the power of 5 to the power of 3 plus, for the next alphabet it's going to be 2 into 5 to the power of 2 plus it 3 into 5 to the power of 1. And for the next alphabet it's going to be 3 into 5 to the power of 0. Likewise, we have converted the first string. So when we calculate this, it's going to be about 193. It's going to be, we gonna get 193 after calculating this. So for first string, we have converted it into a single number. So after converting all the 4 other strings, we'll get the values to be like this. For second string, we'll get the value to be 1628 after converting the Radix notation into a single number. And the first, third string, we are going to get 500. The fourth string, it's going to be 789. And for the last string, it's going to be 1969. So after converting these strings into single values, we are going to use a hash function on these uh, numbers. So here they have given a hash function to be h of k, which is k mod 7. So we here k is nothing but the values which I have got after converting the radix numbers into single value. So these single values are nothing but k values. So we are going to divide these single values with so 183 mod 7. We are going to get the hash value to be 4. So likewise, we are going to calculate the hash for all of the above numbers. So when we divide this, we are going to get the hash value to be 4. Here we get the hash value to be 3. Here we are going to get the hash value which is to be 4 again. And next we are going to get the hash value to be 2 for the last one. So likewise, we got the hash values. These hash values are nothing but um, where are nothing but the places where we have to place our strings. These are nothing but representing the indexes where we have to place our strings. So based on the above, we can place the values in these indices. By looking at the above, I'm going to paste these here. So by looking at the above, we have got three indices which are to be same. So we have to place the three strings in the same index. So there is a we can say that there is a collision which have occurred. So re, uh, to solve this collision, we are using chaining technique. So in chaining technique, we use lists. Uh, Elements are stored in a list, so each list in the hash table can hold multiple strings. So by u- by using a list, so this is about chaining. So here we have a hash table which is of size 9. So we are going to get the indices of i1, i2, i0. We are going to start indexing with 0, i1, i2, i3, i4, and so on. I8, since the hash table is of size 9. So we are here the elements are placed in lists since we are using chaining technique. So the first element is placed at index 4. First string is placed at index 4. So this string is going to placed at index 4 here. And the second string is also going to be stored at index 4 since the hash value represents its index to be 4. So, and the next value is going to be placed at third string, which is our uh, element with the hash value to be 3. So it is going to be placed here. So, and the fourth string is going to be placed at 4 since its hash value is set to be 4. So, and the last string is going to be placed at index value 2. So, likewise, here we have solved the collision by using chaining process. In chaining, since we used lists here, so when a collision occurs, it means we map the multiple strings to the same slot. So we are adding the new string to the list